Live. Okay, the review. Okay, Chapter 7 review. It is 11, 25, 19. Let's see if I can wake you guys up. Okay, number one, find the next 5 terms and a rule for it. Okay, so, and I'm going to do this on a separate sheet of paper. I'll try and be as neat as I can. So number one, I've got 50, I've got 40, 30, 20, 10. So the next one, what am I doing? Going down by 10s. Everybody agree with that? So if I need the next 5 terms, then we're just going to go 0, negative 10, negative 20, negative 30, negative 40. Okay, thumbs up. That's pretty easy. Everybody should be able to do that, correct? Now the rule. To make a rule, ask yourself this. Is it arithmetic or is it geometric? Is it arithmetic or is it geometric? Arithmetic means you are adding the same thing each time. Geometric means you are multiplying. Okay? So which one is it, arithmetic or geometric? Arithmetic. It's got to be arithmetic because what we're doing is adding a negative 10 or subtracting 10. It's not geometric. You're not multiplying. So it is going to be arithmetic. Because you are subtracting 10 each time. Now if you need a rule, to have a rule, we need a formula, okay? A rule is like a formula. And we need a variable. So keep n is going to be our variable. So in order to make a rule, we need a variable. So we're going to keep n as a variable. So I'm going to start right on with my rule, okay? Find my arithmetic rule here. I'm going to put that on my paper. Say a of n is equal to a1 plus n minus 1 times d, right? So a rule would be a of n equals, well, a1 is 50 plus, we need n to be the variable, n minus 1, and d is the difference, which is negative 10. Okay, this is the answer. However, if you put that answer, I would not mark it wrong. I would not mark it wrong, but I'm going to tidy it up, okay? I'm going to make it look better. So I'm going to say, okay, a of n is equal to, let's see, that's going to be a positive 10, so I'm going to have a 60 minus 10n, okay? There we go. How's that? Number 2, and if I get going too fast, tell me, okay? Number 2, so if I take a look at number 2, I have, I'm going to scoot it up here, so I've got a negative 6, and comma 12, comma negative 24, comma 48, comma dot, 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 okay? So, what's going on? I mean, what do you guys see? What's going on?
Multiplying by negative 2.
Good, I like that. So r, we're going to call it r is negative 2, okay? So let's just make the next 5 terms. I'm going to use my calculator though. 48, what is 48? Clear, 48 times negative 2 is negative 96. Times negative 2 is positive 192, times negative 2 is negative 384, times negative 2 is a 768, and then a negative 1,536. Okay, that's easy, right? Everybody agree? You can get that. Now the rule is easy too. Honest, the rule is easy. Because if we're multiplying by 2, it is geometric, right? So there's your formula right there. We just keep n as a variable. Okay, so to make a rule, we're going to go, okay, I'm going to go a of n equals a1 times r to the n minus 1 power, right? First term, a of 1, so I'm going to go a of n equals, let's see, first term is negative 6. Lily said the r, or the multiplier, is negative 2. To the n minus 1 power, okay? Don't multiply those. Don't. It goes against the order of operations, right? Order of operations say you're supposed to do this. Leave that just like that. You're done. That's the formula. Dang, Mr. Davies, that was easy, huh? I can hear you thinking it. Maybe. Okay, let's look at number 3. Okay, number 3 is 2/3, comma 3/4, 4/5, 5/6, dot, 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 okay? Now this one's kind of hard because it's neither arithmetic nor geometric. But here's what we know. N is always these numbers. 1, 2, 3 dot 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 dot. So take a look at what's going on. I don't have 1, 2, 3, 4, but I've got 2, 3, 4, 5. So as a rule, I've got my n plus 1. And on the bottom, I'm going to have an n plus 2. Does that make a little sense how I got that? If I plug in 1, I get 2/3, right? If I plug in 2, I get 3/4. If I plug in 3, I get 4/5, and so on, okay? Maybe do that tomorrow, hopefully. All right, 3, that's 3. All right, number 4, okay? Let's write this in summation notation, okay? So number 4, no matter what, I'm going to start with this. Summation notation. Write this symbol down. When you see summation notation, we're going to write that symbol down, okay? Here, Jay. I'll just and then if you want to watch the film it right now. Okay, so you ready? Number 4. I'm going to start with summation. Boom, 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 right? And if I need a rule, right? If I need a rule, then I've got to use either this one, or this one, or if it's neither one of those, I've got to make something up. But if I take a look at it, Ethan is waking up for me. I know he is. So if I take a look at this, what's going on? All right, we're adding 2. So my rule's got to be arithmetic, right? So if I need arithmetic, I'm going to put this down. I'm going to go A1 plus n minus 1 times d, okay? Good, we got to start. We have to have summation because it says summation notation, okay? It is adding 2, so it makes it arithmetic, so I write this word down. So let's see what we can do. So I'm going to go the sum, and I like to start at 1. We always like to start at 1. Always start at 1 because you plug in 1, then you plug in 2, plug in 3, right? We're going to have a 12 here plus a n minus 1 times 2, right? And then I'm going to tidy that up. And that's going to give me a, let's see, a 2n plus 10. Now, okay, I got to highlight this so you guys see this. Okay, now, what goes here? What goes there?
130.
Really close. You're so close. What number plugged in would make 130, right? So let's work it backwards. What number plugged in here? What if I plugged in a number here to make 130? So let's work it backwards. Let's just take our 2 on the side, little side work. Let's take our 2n plus 10 and set it equal to 130.
It's 60.
Because then I would know what number plugged in would make that. So I got my formula, and we're going to say, okay, what n would make 130? Because that is last term. You're right about 130. Okay, so if I minus 10, divide by 2, it's got to be 60. So if I plugged in 60, I'd make the last term. Okay, thumbs up. You have to have this tomorrow. Okay, number 5. All right, so 5. Okay, summation notation. I have to start there, okay? Got to start there on number 5, okay? Put this up here so you guys can see it. Give me a second. Okay, there it is. Boom. Okay, got to have that, right? Now, what do you see? What's going on number 5? Let me slide it down. What do you see? Say it again. You guys agree multiplying by 5, which means it has to be geometric, so we're going to use that formula there, okay? So I want to use that formula there. I'm going to go, okay, I'm going to go A1 times R to the n minus 1 power, okay? So let's put in what we know. Let's go, okay, summation n equals 1 of 2. What's our multiplier? Caden said 5, right? To the n minus 1 power. Okay, so far so good. This looks great, except, one more time, we got to figure out what goes there. So, Austin, we know that whatever we put in here has got to make 781,200. 250, right? So let's take our formula and set it equal to it, okay? So I'm going to go 2 times 5 to the n minus 1 is equal to 781,250, right? I got to solve for n. I can do that. What do you think the first step's going to be? Let's divide by 2. Divide by 2, divide by 2. I'm going to borrow Jay's calculator. Okay, 781,250 divided by 2, and I get 390,625 is equal to 5 to the n minus 1 power. Okay, now you got two choices. We could just go 5, we guess and check. 5 to what power, 5 to what power, 5 to what power. We could guess and check. I guess, okay, well, 5 to the, I don't know, 5 to the, whoops, clear. 5 to the, give me a number, 10th maybe? Too big. 5 to the maybe 9th? Too big, okay? Or we could go back to something we learned last chapter. We could say log base 5 of 390,625 equals n minus 1. Remember doing logs? Remember doing logs? Hey, we're going to use some stuff we learned a long time ago. So if I do my logs, right, I'm going to just use my math. Ah, we're using logarithms. It makes me so happy that we're actually doing logarithms. Where's my log button? Oh, I got the wrong calculator. Anybody have a new one? I'll borrow Parker's. Parker. Okay, remember how we did this? I want the log of that. I'm going to go back to math. Log base 5 of 390,625. I get 8. Okay, so I get 8 equals n minus 1 plus 1 plus 1. N is 9. So 9 goes right up there. The other way is guess and check, guess and check, guess and check, if you don't want to use logarithms. But logarithms are pretty easy. Okay, you ready for 6? Okay, 6 is the easiest. It really is the easiest because when I do this on 6, swear to goodness, 6 is easy. Because when I do my summation n equals 1, I already know what goes up here. What goes up here? What goes up here? Dot, 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 dot. What goes up there? Infinity. See how easy this is? Dot, 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 dot. So I already know that this is infinity, okay? So I don't have to do that hard work with logarithms or anything like that. It goes to infinity, okay? Now, tell me what's happening. Tell me what's happening. Divided by 4. Or, yes, totally right, or I'm multiplying by 1/4. You okay with that? So I'm going to use my a1 r to the n minus 1, because if I'm multiplying by 1/4, it's geometric, right? Or divide by 4, so it's got to be that one, right? And I'm just going to go, okay, here's my summation. N equals 1 to infinity. A1 is 400. My multiply is 1/4 to the n minus 1 power. And I'm done because I already know the last term. I know how many terms there are. There's an infinite amount of terms, right? How am I doing? Good. Good, Julia. Whisk this away when Julie gives me thumbs up.
I have a question.
Yes.
If the n, like when it says n equals 1, if it were to be something else, would that just mean it was a different
How do you,
term?
when would it be something?
Would it be a to the 2 then?
Yeah, great question. I'll show you. If you had this, just let's say it's this summation n equals 2 to say, I don't know, let's go 8, doesn't matter. But let's go 3 over n minus 1. Okay, now, if I started at 1, what's going to be the problem here? Right? So sometimes problems will do that just to make sure that you don't make a mistake like dividing by 0, okay? But for us, Julian, most of the times we're going to start with 1. Because the numbers we plug in are always 1, 2, 3. Good, really good question. Really, really good question. But that's an example of why we wouldn't want to start with 1. Okay? All right, so let's take a look. Okay, number 7. What do you think? Looks like I've got let's see, if that's 2, then that looks like I've got a value of, let's see, A1. If I look carefully, that looks like 1/2. A2 looks like it's got a value of 1. A3 looks like it's got a value of 2. A4 looks like it's got a value of 4. A5 looks like it's got a value of 8. A6 looks like it's got a value of 16. So tell me, what do you think is going on in 7? I'm just doubling, right? So, easy question. Is that geometric, arithmetic, or neither? Definitely geometric, right? So this one's geometric. I agree. If we want a rule, we've got a rule for geometric, but we've got to keep the n as the variable, right? So, okay, I can do this. Definitely geometric. We're going to go, okay, a of n is equal to a1 times r to the n minus 1. So let's fill in what we can. A1 is 1/2. That's my first term, right? Cadence right, the multiplier is 2 to the n minus 1 power. There's my rule. It's geometric because we're multiplying by 2. I took my geometric formula. I plugged everything in except I kept n as a variable so that I can make a formula, okay? How am I doing? All right, let's take a look at this one, this next one. Let's see. A1 looks like it is 1. A2 looks like it is at 3. A3 looks like A3 is at 5. A4 looks like it's at about 7. So what's going on? What's going on? Adding 2, so it's arithmetic, right? We're adding 2, so this one's definitely arithmetic. Okay, if we need a rule, we're going to use this one, right? Arithmetic, we're going to use this one. You start to get the picture of how we do this stuff? Okay, so if we need a rule, it's arithmetic. We're going to go an equals a1 plus n minus 1 times d, and we'll just plug in the stuff we need, keeping n as a variable, okay? Let's go an is equal to a1, which is 1, plus n minus 1 times 2. And that answer is okay. I would not mark that answer wrong, but I'm going to tidy it up, okay? I'm going to rewrite as an equals, let's see, that's a negative 2 to n minus 1. There we go. That's the rule I would use, okay? I will, yeah. Okay, there you go. Okay, you ready for 8? I think I can probably fit 8 on my paper. So number 8, arithmetic. It's arithmetic. So I'm going to start with my rule. An equals a1 plus n minus 1 times d, okay? So we've got to find the first term. So if I take a19, so if I use a19, then I'm going to let n equal 19 because a of n is negative 45. So I'm going to go negative 45 equals, and I don't know a1, but that's what I want to find. I'm looking for a1, right? It says find a1, so I'm going to go a1 plus. Now, I said n is 19, because if I plug in 19, I'll get 45. 19 minus 1. And it says the common difference is negative 3. Okay, so now it's easy. We just have to solve for a1. So, I can do a little bit of algebra here. Negative 45 is equal to a1 plus, oh, let's see, 18 times negative 3, what's that, 54, maybe? Clear. 18 times negative 3 is negative 54. There are days. Negative 54 plus 54 plus 54, right? Okay, so then plus 45. So I'm going to go 45, clear. 45. Nope. 54 minus 54 minus 45. I get 9. So A1 has got to be 9. Okay, now the rule is easy, right? We'll just go back up to here and plug everything in. So our rule is going to be A of n equals A1, which is 9 plus n minus 1 times negative 3. And again, I would take that answer, but I'm going to tidy it up because I like it tidied up. I'm going to rewrite it as an equals, oh, let's see, that'd be a 3, it'd be a 12 minus 3n. Okay? How am I doing, okay?
So you wouldn't plug in 19 again for n?
If I did, Julia, guess what I'd get? If I plugged in 19, guess what I'd get? Negative
Oh,
45.
we just did that, okay.
Yeah. Good. You're asking good questions, though, Julia. Okay, turn the page. Thumbs up. Okay. All right, we're getting there, okay? Okay, number 9, and I'm going to have to use a separate sheet of paper to do these, okay? Number 9, okay? Everybody see that? So, what we're going to do is if we plug in 1, we get 1's 5, we get 3, okay? We plug in 2. If I plug in 2, I get 10. 10 minus 2 is 8. If I plug in 3, let's see, I get 15 minus 2 is 13. What do you see what's going on? What's going on? Yeah, and then what I want to do is add them all up, right? So, arithmetic, everybody agree? Arithmetic sum. So it's arithmetic sum. There it is. S of n, arithmetic sum. That formula right there. So we're going to go, okay, I can do this. S of n equals my n times a1 plus an divided by 2, right? Okay, I know n. What's n in this case? What's n going to be? N's going to be 30, right? N's going to be 30. I know the first term. I know a1's 3. I know n is 30. What is a of n? Yeah, we just plug in 30. So a of n is really a of 30, which is 5 times 30 minus 2. 150 minus 2 is 148, right? 148. So we're just going to use our formula. So we're going to go, okay, I can do this. I'm going to put my 30 here. I'm going to put my 3 here. I'll put my 148 here and just use my calculator. So S of 30. 30 times 3 plus 148 divided by 2. Calculator time, right? Clear. 30 times 3 plus 148 divided by 2. And I get a grand answer of 2,265. Okay? Not bad? 10. All right. Guys ready to do 10? Well, when I look at 10, I already know it's geometric. I already know it's geometric because it fits this formula perfectly. You guys see that? Okay. If it fits that perfect. I already know the multiplier is -2. See that's right there? R is -2. I already know the first term is 18. You guys all right? See how that works? So if I want to find the sum, I'm going to use the sum formula. Okay, so I know it's geometric. It fits the geometric form perfectly. So number 10, yeah, I know it's geometric, which is an equals a1 times r to the n minus 1. So in this case, I already know a1 is 18. And I know my multiplier is -2. So I got to find the sum, because that symbol, that funny little symbol, means find the sum. Okay, so I've got a formula. The formula I want to use is this one here. So I'm going to go, okay, S of 10, right? S of 10, which is going to be A1, which is 18, times 1 minus -2 to the 10th power, all over 1 minus a -2, okay? Now, on my calculator, I got to be a little bit careful, okay? I got to be a little bit careful. I need parentheses. Oops, parentheses. And to make it easy, I'm just going to make that a plus in my calculator. You guys okay if I make that a plus in my calculator? Why not, right? So, you got to be careful. I'm going to go 18 parentheses. 1 subtract parentheses, I need a -2 to the power of 10 parentheses divided by 3. Okay? I get an answer of a negative 6,138. Okay, just have to be careful with your parentheses, all right? Okay, all right, yeah. Number 11. Okay, number 11. Oh, I see an n squared, don't I? So there's two ways to do 11. Make all of them or just use a formula. So I'm going to use the formula. The n squared formula. My n squared formula is going to be my n. I can move my paper right there, okay?
Is this
Yeah.
numbering on number 10, would A1 not be a negative 18?
No, it's positive 18 on number 10.
The negative 2 to the 0 power is a negative 1.
No, to the 0 power is always 1. Just the number 1. Anything to the 0 power is always 1.
Okay.
Honest.
In the calculator it says the same.
Let me see. Okay. Let's go back to this. Okay, n squared. Hey, there it is. N squared. You guys see it? N squared. So there's my formula. N squared is n times n plus 1 times a 2n plus 1 divided by 6. N, I got an n formula too. It's not up there, but I got an n formula, and that is plus an n times an n plus 1 divided by 2, right? So that's my n formula. You guys want me to put the n formula up here too? Sure, why not, right? Where n is equal to, let me get my darker, n times n plus 1 divided by 2. So we have every formula we can possibly think of. So I'm going to plug in 7. So I'm going to go, so n is equal to 7. So I'm going to go 7 times 7 plus 1 times a 2 times a 7 plus 1 divided by 6 plus a 7 times a 7 plus 1 divided by 2. Okay, calculator time. 7 times 8 times 15 divided by 6. This is 140 plus, let's see, that's going to be 7 times 8 divided by 2. 7 times 8 divided by 2. That one's 28. If I add these together, I get 168. Okay? What do we do? Well, we just added all 7 terms up, but we did it with a formula. Much easier. Okay? Autumn ask.
I don't get the plus n plus 1 over 2. Why are you adding the second?
Right. So what I'm doing is this. I'll do it real quickly. Okay. If I plug in 1, it's 1 squared plus 1, right? Plus, if I plug in 2, it's 2 squared plus 2, right? If I plug in 3, it's 3 squared plus 3, right? Right? So the n squared formula gets all of the 1 squared plus 2 squared plus 3 squares, right? But I'm also plugging in 1, 2, 3, 4, so I've got to add all those up, right? And so I've got a second formula for that part. And again, on these, if you want to just make the darn thing, you could, and use your calculator to add them all up, because not everybody likes formulas. Okay, so 12, one of the easy ones, okay? 12 is an easy one, okay? So 12 is, it definitely is geometric, and you're going to be going down. So it's going to infinity. We have an S of infinity formula, okay? So on number 12, we have a formula. We learned this Friday. We've got an S of infinity is equal to A1 over 1 minus R, okay? I know A1 is 100. So I know A1 is 100, and I know my multiplier is 1/5. So S of infinity is equal to 100 over 1 minus 1/5. So if you missed Friday, this is what we did. We're going to infinity, and the multiplier needs to be less than 1. So real quick, what this is actually is 100 plus 20 plus 4 plus 4/5 plus 4 25ths plus forever, right? So Autumn, you weren't here Friday, but it's really pretty easy. Okay, if I plug in 1, I get 100. If I plug in 2, I get 20. So I'm really taking a fourth of it, forever. And since the pieces are getting smaller and smaller and smaller, eventually, the last piece we add, if we could get to infinity, would be 0, right? So we should be able to add them all up. So we have a formula, and this is our formula right here. Okay, so we're going to have 100 divided by 4/5. That's the same thing as 100 times 5/4 because I invert and multiply, which gives me 125. How's that? Okay. All right, almost done. Recursive formulas, it's easy. You need two things. I'll say it again. You got to have two things. Tell me the first term and then give me a rule. So A1 is -1. This is what we learned today, right? And then a to the n minus a to the n equals a to the n equals a to the n minus 1. And then what's going on? What's going on? How am I making each term? How am I making each term? Times by -3. That's it. That's it. There's my rule. I have to have the first term, and it says to make the next term, take the previous term and multiply times -3. Easy, okay? 14. I got to have the first term, A1 equals -24. And then what's going on? What's going on? My minus an 8 each time, right? So if I minus an 8, so a to the n is equal to a to the n minus 1 minus 8. That's it. You have to tell me where to start, and then say take the previous term and subtract 8. Take the previous term, subtract 8, okay? 15, okay? Now, if we want to read recursive formula, the first thing we got to do is figure out what's going on. So, what's my first term? A1. Got to know A1. Okay, A1 is 11. And I might need to make a few of these on 15. So on 15, A1 is 6 times 1 plus 5. A1 is going to be 11, okay? So A2, what's A2? Well, that's going to be 6 times 2 plus 5, which is 12 plus 5. What's 12 plus 5 is 17, right? A3, let's see, A3 is 6 times 3 plus 5. Let's see, 18 plus 3 is 23. What's going on in this problem? What are you doing? You're adding what? Adding 6. So where are we going to start? What's our first term? What's our first term? 11, right? So we got to start at 11. So we're going to go A1. Here's our rule. A1 equals 11, and a to the n equals a to the n minus 1. And what's our rule? You guys said it was to do what? Plus 6. Boom. There it is. Okay. All right. 16. We already know our rule. We do, because it says R, right? So what's our first term? We know our first term. So go, okay, A1 is 48. I got that. And a to the n minus, a to the n equals a to the n minus 1. What's going on? We're multiplying by 2/3. Yeah. Last but not least, we're done, huh? Almost done. Okay. Are we good? 17. So this is like an infinity problem because when you get medicine, traces of it remain in your blood, traces of it, right? And those pieces kind of add up to give you what we call like a leveling off amount. All right, so if I start with 250 milligrams, and then, you know, only 12% of it's left, right? So I'll take 250 times 0.12, then I've got 30 left over. And then if I take, you know, 12% of that, then I've only got 3.6 of it left, right? But then you keep taking medicine and it bumps it up, okay? So it has a leveling off period. So if we use our S of infinity, we're going to take A1 over 1 minus R. Now we're going to consider A1 our first term, which is really kind of like the last term, believe it or not, because this is the term you're going to take and all the traces are still in your blood. So that's 250 divided by 1 minus 0.12. And I'm just going to use my calculator. 250 divided by 1 minus 0.12. I get an answer of about 284.1 milligrams of medicine. And that's the leveling off period, okay? All right.